Welcome guys to another video. Today I'm going to solve this limit using this what we call squeeze theorem. So I hope you enjoyed the video and let's go for what matters right now. So first of all, I see sine here, right? I'm always starting with sine, cosine when I'm dealing with these limits because I know that sine or cosine of something is bounded between 1 and -1. So my goal here is to, starting by this, I can achieve something like this. So I see that sine here, its exponent is 2, but there's a problem here. I cannot take 2 as exponent here because of this negative. If you see, for example, you have -3 is less than 0, right? Is less than 0, right? If I take 2 as exponent here, what do we get? We get 9, here we get 0, and this is false. That's why we cannot take 2 here, take any exponent here, we cannot. So yeah, that was an example. Of course, if you are a mathematician, you can prove it. Okay, so what I'm going to do here, I can say sine of x, its absolute value, is less or equal than 1. So what I can do now, I can do what I wanted. Put 2 as exponent here. So what I get is this here is 1 square. There is no need, right? So I know that this from now on is what this from now on is greater, yeah, this is greater or equal to than 0. So here we get 1, right? So now I have this, it's still okay. So I can add the 1 every members here. So 1 plus 0 is 1. Here we get 1 plus this. So here we get 2, right? 1 plus 1 if I add 1. Now this will be always positive. If you see as x approaches infinity, there's no need to worry about the signs here. So I can just multiplying and dividing at the same time like this. It's multiplying, same difference. So what do get? Okay, now I get this x plus sine of x square. Right here I get this 1 plus sine square of x over this square, then it's 2 x square over this, it's sine here over this. Good. Now what I can do, I can plug in limit here every side here. I can do that. So what I get here, it's limit as x approaches infinity of this x plus sine of x here. So this is the limit that we wanted, that I'm writing right now. Good. So here it's x plus sine of x, this. Good. So I can take out 2 and write this limit, right? X square, this. Good. Now you see something very interesting. We have this and this limit, they are both equal, right? But here we have 2. So now I need to know how to evaluate this limit. Perhaps using squeeze theorem, perhaps. Perhaps, but squeeze theorem will take much time. Okay, let's manipulate this. Let's do like this. Here I get, now I want this limit. Let this equal to L, let this equal to L, right? It's above equal. So now I want this limit. So if we use the property here, we get x squared plus 2x sine of x plus 1 plus sine square of x, right? So yeah, what I'm going to do, I can divide here by x squared and here by x squared, right? So what I get, we get this limit x approaches infinity. Here I get x approaches infinity. Here we get 1 x squared divided by x squared 1. Then if I get this divided by this, we get is 2 sine of x over x plus this. I can do like this, everything to the power of 2, right? Now some of you will think that yeah, it's equal to 1, but remember that happens when x approaches it's 0, I mean, but here it's infinity. So what I'm going to do is, let's analyze. It's really good to analyze. Here we have 1 plus this limit. If you see, when x approaches infinity, this function will always oscillates between -1 and 1, and this will take greater numbers as it approaches to infinity. So here will be oscillating between -1 and 1, and this perhaps a billion, I don't know, it's infinity. I've never seen infinity, but it's like this. Then here we get 0, and here we get 0 square. So here we get 1. So this limit it's equal to 1, right? And this is equal to 1. So I can write this, the limit that we wanted, it's this 1 plus sine square of x over x plus sine of x square. Here it's 1 is 2 times this limit that is equal to what? 1. So here it's 2, and here what we get, it's 1. And as you see, this limit here, we have in this limit, when we have this 1 and 2, and when we use is what we call squeeze theorem, and we have different values here. My friend, you can write this. The limit doesn't exist. Damn, the limit doesn't exist. Look, all of this just to say this. I'm not kidding, man. I'm not kidding with you. I know that you wasted perhaps it's 9 minutes here watching this video, and to get this, it's normal. So guys, thanks for watching. See you on another video.